Let me pull up the problem that I started with earlier today. Let's see, it was So, as of right now, when we've done completing the square, we've always done it when your A value is equal to 1. Our B value, if you notice, more often than not, our B value wound up working out to be even. We like even B values because taking half of an even number is fairly simple. When we take half of an odd number, then we were left with fractions. Now, a lot of times the fractions that we dealt with weren't terrible, but they were more of a pain in the butt to work with. Do you agree?
Yes.
So what I want to get at today here is to start to get you guys to realize that there's more than one way to solve these problems. I'm going to talk about leading term not 1. We're going to revisit the what do you call it? The factoring idea, as well as talk a little bit about quadratic formula. So when you have a leading term coefficient that's not equal to 1, and you want to complete the square, all you have to do is divide everything by A, whatever A is. The only way you can complete the square is if your A value is 1. Okay? It's the only way you can do it. So you have to divide everything by 4. And by doing this to both sides of the equation, you're keeping everything balanced. That's the only rule you have to worry about when you're completing the square and your A value is not equal to 1. What's 0 divided by 4? Okay. And then go from there. So now, all you have to do is go through the steps now. Really, in all honesty, it's just adding one part to it. Is your A value 1? If not, divide everything by A. Yeah?
What if A value is different number? Like, if it was like 3x squared with the rest of it,
Uh-huh.
didn't work, would you just do this?
You can still do that. You can still divide everything out by the A value and work, but there's a better method when it's like that. And we'll talk about it. Exactly.
But like,
Because when I get to the point here, when I get to a lot of these things, I want to show you guys the different methods, but I want you to choose what works best for you. Now, there are times that when I see something like this, I'm immediately going to complete the square because I know my B value is going to be even. It's fast. I think it's a very efficient method to do it. I probably wouldn't use quadratic formula in something like this because I can mess a button up here and there. But this is a very straightforward, it's almost like a very mental workout for me. Not workout, but it's a mental way to solve the problem. If I'm going to use quadratic formula, and like you said, if this was a 3 and nothing works out, yeah, I'm going to use quadratic formula and use fractions all over the place. Yeah.
oh, shoot, I forgot.
Let me know when you remember, and then I won't answer it.
All right.
So your first step then, move C. What's half of 10? Goes in your parentheses. 5 squared is? Negative 70 and 25, I believe is, was it 45? Negative 45? And then square root of negative 45, you might be able to know that one. 3 root 5, but 3i root 5, very good. When we square root it, we're going to get x equals negative 5 plus or minus 3i root 5. Now, can you combine integers and imaginaries? No, cannot. Treat it like a variable. There's been times when people have tried to do, let's say the question was 2 plus 3i, or 2 plus or minus 3i. Some people were writing 5i and 1i. No, guys, remember, when you have an I value, treat it like you would as you're combining like terms with a variable. Yeah, Haley?
So like, I'm confused on how you got 3 root 5.
45, the square root of 45, that's the same thing as 9 and 5. I slapped an I in it because it was negative.
I
So you just find like two numbers, like, I don't know, I'm trying to square.
Remember the trick to do that in your calculator?
I always find the prime
What
factor.
equals the number divided
Remember, the trick for doing this in your calculator to see how it simplifies out, go to your y equals table, and what it's doing is if you take 45 divided by x squared and go to the table, it's going through all the calculations of 45 divided by 1 squared, 45 divided by 2 squared, 45 divided by 3 squared. It's checking to see which squared term goes into 45 evenly before dropping to all decimals. So that's where we see that if you look at it, 1 squared, 45 divided by 1 squared, 45. 45 divided by 2 squared is 11 and a quarter. 45 divided by 3 squared is 5.
So you find the one that's, find the first one that
It's not the first one, it's the last y value before everything goes all decimals. So it'll be 3 root 5. Okay? Works every time.
is there a way to like select a y, like search for a y?
Yes, absolutely. You can do that. It's under your window. You hit second table set, and in there it says independent, dependent. Switch your independent to ask, and then it'll. If you wanted to check numbers, then this is kind of like if you go to your table, it's like plug and chug. So I want to know. Oh, if I put a 2 in, I get that. I put 5 in, I get that, and so on. It does it for you. Okay. We don't use that a lot, but it is.
Like, we were talking about you did that and like I didn't know how to search through the whole y.
Yeah. Well, you mean search through x to find the y?
Or yeah, I mean,
Yeah, that's. You might use. We might use that a little bit with exponential stuff. You might see how you search, how it's easy to find where things are moving towards. Not terrible. Okay. Now, the other thing I wanted to show you was the quadratic formula. The quadratic formula is another means to simplify or to solve for your zeros for any quadratic equation. Remember, the generic standard form of a quadratic equation is ax squared plus bx plus c equals 0, where your values of a, b, and c are your coefficients. Okay? By using the quadratic formula, you can find zeros and calculate zeros just by pressing a bunch of buttons. Okay? This is a very efficient method when you have really crummy numbers, where nothing works when you have an a value that doesn't divide out cleanly, or you're given ones that have decimals, or you're given ones that have fractions and stuff like that. It will give you the plus minus stuff as well. You can solve it with imaginaries. You can solve it with integer values if something is factorable. Quadratic formula is another one of the methods that will always work. Do you remember the song? X equals negative b plus or minus square root b squared minus 4ac all over 2a. You don't remember that? You were never taught that? You know, I'm sad to hear that you never taught that. So your job, if you choose to do it, is to come up with your own original song. Perform it, record it, email it to me, and it's due the Tuesday we come back from Columbus Day. Yeah.
In this little girl's class, we had to watch a video of a bunch of teachers singing.
Seriously. Yes. So, hey guys, let me explain this real fast. I do this little fun project thing with this annually. I do this every year, and I try to get you guys to create your own music video, if you will. Record it, put it on YouTube, email us the link. I try to keep you guys into groups of no more than 4, because if you get more than 4 people going into groups, a lot of times someone's really not doing anything. You can do it solo. You can do it with 2, 3, 4, whatever. Original work, please. I know how to Google quadratic song videos, and I can see how much you rip them off. Generally speaking, we always have a good time with this. Usually I don't give as much time to do this, but last year I don't think it worked out where it's the weekend of homecoming. So that's why I decided not to be due next week. What I'm looking at doing, since this weekend is homecoming, the following weekend you have a 4-day weekend for Columbus Day. Because we had teachers that have institute on that Friday, and then you guys have the long weekend. So what I've decided is that I will let it be due, that would be what? The 11th. So we don't have school on the 10th. Submissions must be done and emailed to me by the 11th, okay? And then just post them through that way. We'll watch them that day. We will laugh at you. It's part of the fun. I usually throw a few questions, a few points, about 5 or 6 points into a quiz category for it. So if you start thinking about it, it's worth a few homeworks. Popcorn?
Is it just a song about the quadratic?
Yeah.
How long does the song have to be?
Usually people make them within it's usually a couple minutes.
Does it have to be good tutor video?
Like a whole song?
Whatever you want. If you, sure. It can be a little bit better than that. Think creatively. Yes, sir. Guys, you can't hear it.
Could you have the quadratic formula in it? Have other math stuff as well in the song?
Sure.
Yay.
There's lots of different things you can do. Remind me, when we finish here, I have one animated one to show you. All right, is that a deal? All right. So, like I said, with the stuff that we work with quadratic formula, a lot of times I would use quadratic formula for something like this. It happens sometimes when I use a little snapshot thing. I think using quadratic formula is very easy to do when you have crummy numbers. It's very easy. The one thing that I will warn you about with the quadratic formula, when you take the opposite of b, if your b value is negative when you throw it underneath the radical, remember you have to square it. If it's negative, you got to make sure you put parentheses around it, because I guarantee half of you will screw that up. Okay? So in this case here, you've got a, b's, and c values. Sing the song to yourself a couple times. X equals negative b plus or minus squared b squared minus b all over 2. Anyway, and then you just fill in the blanks. Okay? You got negative 5.6 plus or minus the square root of 5.6 squared minus 4 times 1.4 times 3 all over 2 times 1.4. I will also suggest anytime that you're working with a quadratic formula, do not try to put it on the calculator at once. You will screw up. Not that I don't believe that you can do it, but just don't. What I would do, what's that? Yeah, no, it's not. What I would do is figure out what's underneath the radical first. Do you know what that's called? The b squared minus 4ac. Have you ever heard of the term called a discriminant? The discriminant is something that's important that we will talk about tomorrow, what it can show you from just knowing what the discriminant value is. So I would just throw that in the calculator first and work my way out. So let's see here. We have 5 point. There is not. That's why I said you can't do it all at once. There's my discriminant, 1456. Okay? So I would just rewrite my formula. It's negative 5.6 plus or minus the square root of 14.56 all over 2.8. I don't believe 1456 is going to be a perfect square. But do you know how to, when I get 14.56, you know how to check the square root of that without having to retype it? Hit second square root of your answer. Use the answer button. All right, use the answer button for the last answer you get. And those are your values. Obviously, it's not a perfect square, nor is it even close to one.
Wait, can you X out?
Yeah.
So you have to write that?
I'll show you what I would write. So the problem itself was given us 2 decimal places, or sorry, 1 decimal. Personally, I always, whenever I'm rounding decimals, I always go 2. So all I would do is this, negative 5.6 plus or minus 3.82 all over 2.8, and I call it a day. And that's a legitimate answer.
That's it?
That's it.
Oh, cool. So X equals that?
That's it. That's all you have to do. Anytime you have to round with the calculator, and you're only going to be rounding with the square roots if you're taking the square root of something that has a decimal. Every other time, you're going to be simplified radical form. Does that make sense? Because all the other simplified radical form stuff you'll be able to work through without a problem. Decimals, you can just leave them as a decimal. This Hopworth, you look perplexed.
Well, I was just wondering if we have like a fraction as b, would you still just like throw that in there?
Yeah, absolutely.
And so would you want the number to come out as a fraction? If that's what
When you're, it depends on how you type it through. A lot of times if you're using quadratic formula and you have a b value that's a fraction, you're probably not going to get a clean number. You'll probably get a decimal value, and that's okay.
So use the decimal or the fraction?
Well, it depends on what if the radical winds up being like the square root of 12 over 5, you can rationalize and simplify. Yeah, something like it's something clean like that. But if it's like decimal hell, just worry about it then. All right. So that's what we use a quadratic for. Question on that?
So if there were like regular whole numbers, you'd want to section the answer.
Yeah. Yep. And like I said, quadratic formula, completing the square, all those things all work even if something's factorable. So, actually, I'll do this one be double. Yeah. Which one is it? This one here. If I look at this one, x squared plus 4x minus 12, isn't that factorable?
Yes.
It is. Wouldn't that be the fastest way to do it? But if you don't recognize it right away, what could you do? Any quadratic formula I can complete. Why would I probably complete the square and not use quadratic formula here? It's even. Yeah, it's faster. So let's say you don't recognize your multiples of 12. X squared plus 4x plus blank is 12. And just work yourself through it. And see how fast that is to complete the square?
Yeah, I'm staying with that.
And there's nothing wrong with that. Okay, there's nothing wrong with that. And then you get x equals negative 2 plus or minus 4, which means your 2 answers are at negative 6 and 2.
So what if it's a solid number, like do you want us to take it like the extra step?
I'd like you to, yeah, if they're countable integer value, I would write it out as negative 6 and 2. Those are my zeros. It works the same way if you wanted to use quadratic formula. Opposite of b plus or minus square root b squared minus 4 times a times c all over 2a.
So you'd recommend doing that when out of cases?
The quadratic?
Yeah.
Crummy numbers.
So basically like not even numbers.
Crummy numbers. 16 plus, what is that? 48. What is that, 64? That's right. Yeah. Because what's the square root of 64?
What's the example of a crummy number?
2.6.
Alright, yeah.
Just like that. And that's the one thing, yeah, Laura, go ahead. And that's the one thing that'll happen sometimes with quadratic formula. It still works out just fine, but you'll notice when you get down to the end, if all three of your parts are simplifiable, I think that's a word. It sounds good at least. Just simplify it, because you're dividing everything out by 2. What's wrong? -2 minus 4.
That's on the other problem.
Okay. So what I want you to work on tonight are those. It's in the same section of stuff. Add to the problems you already have. You now have 3 possible methods to solve for zeros. It does not matter which one you choose. Yeah, you got factoring, complete the square, quadratic formula. What's that? You can, but sometimes, like for number 66, I wouldn't, because I'd have to divide out by my A value, and then I'd have to work with the fraction and go through it. So like on 66, I'd probably use quadratic formula. Probably be quicker. We could also might be able to factor it. Yes, please. Yeah, yeah. I want you guys to go 63 to 72 on these. It's the same. It's the same page. Was it 287? So it's 5.5 in the old book. Yeah, I might have read.
Wait, so the page I have to review from Thursday.
Yeah, that's right.
Oh yeah, I had to ask a question. I have to ask a question.
This will help. You're welcome. I thought I PDF'd that. I'm sorry if I did not.
It was just like a link